Hey, Algebra 1, Catlin here with lesson 26. Really, the last thing that you had to do on your homework. So, we're going to read this problem, graph it, answer the questions, and you should be done for the week. So, let's jump right in. A certain stylist charges $15 for a haircut and $30 for hair coloring. A haircut takes an average of 30 minutes, while coloring takes 2 hours. The stylist works up to 8 hours in a day, and she needs to make a minimum of $150 a day to pay her expenses. All right, so we got to create a system of inequalities that describes the constraints in this particular situation. And we got to specify what the variables represent. Let's start there. So let's start with x, and let's let x represent number of haircuts that she gives. So number of haircuts. Since she gets $15 per haircut, we need to know how many haircuts she's going to give in a day. And we'll let y represent the number of colors. So number of hair colors that she performs. Just because they come in doesn't mean they have to get both. Sometimes they get a haircut, and a color, sometimes just a haircut. And then I guess sometimes they come in and just get colored. So those are representing our variables, things we don't know. And let's see. I think everything else is just money and time, which we can. We don't have to have variables for that. So let's create some inequalities here. We know that let's make an inequality for let's make one for money. I like starting with money. Let's make an inequality for money. So if she makes 15 per haircut, plus 30 per coloring, we want her this expression would represent the total money that she makes. Now, she wants to make a minimum of $150. So that is we want to be at $150 or greater. So that is the inequality that I'm going to write. And then let's make another inequality that represents time. Okay. Every time that I give a haircut, it takes 30 minutes, and that is shown right here, average of 30 minutes. So in 30 minutes, that would be half an hour. So we could say half an hour per x plus 2 hours per coloring, right? She's only got 8 hours a day, up to 8, so she needs to stay under or equal to 8 hours a day. So this inequality represents her timing constraints. This inequality represents her money constraints. And we are going to graph those two things. And I think just to kind of speed up the process here, to make this go a little faster, we're going to graph them on Desmos and then sketch them on here. So let's start with the bigger numbered one, and then we'll throw that one in there, and we can see if we can get a good window for the one we have to draw. Okay, so let's jump over to Desmos. We got 15x and 30y. So 15x and 30y, and we want to be go back here greater than or equal to 150. So greater than or equal to 150 bucks. Okay. We got a pretty good window for that right now. All right, let's jump over to the other one. The other one that we wrote says half of an x plus 2y. So half of an x plus 2 colorings. We need to keep that under or equal to 8 hours because that's how many hours in a day that she has. All right, I think we got a pretty good window here. Let's go. Maybe we can back up just a little bit. Okay, it looks like that one crosses at 16. So let's go to at least 16 on the bottom, and then we don't have to go very high on the top. We can go up to like 8 maybe. So I say we go 16. Let's do 20 and 8 as our window when we draw this. So 20 on the x-axis and 8 on the top. So up here at the top, we can probably count every other. We're going to do 1, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7. Oh yeah, we got plenty of room there. So we want to get to 20 down here, and I think we could probably go by 2. So I'm gonna do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Plenty of space. Okay, so let's graph the first one. All right, so the first one, let's just do the money. Okay, the money looks like it intersects at 5 on the y-intercept and 10 on the bottom. So 5 and 10. So at 5 and here's 10, we've got that one intersecting there. So this represents, okay, so this represents money. Okay, so this line represents money. And then the other one, let's put it back on there. It's the blue one. It intersects at 4 and 16. So 4 and 16 for that one. So let's do that in a different color. 4. Oh, that's ugly. I thought I had my line drawing tool on there. Sorry. 4 and 16, which is there. Okay. So this line represents time. All right. Now, for the money line, let's go back. Let's look at our Desmos. For our money line, which was in red here, we wanted everything above that. So we can shade everything above. So the money, which is here, we can shade everything above it. So that would be everything to the right of the blue line. Okay. And for the time, we had to keep it under a certain time because she's only got so many hours in a day that she can work. So the time was below that line. So time below it would be below the purple, which would put us in the green section here. So where does the green and the yellow intersect? And that would be in the section here, right? Along this line here and along that line there. So they intersect. They overlap in this section here that I kind of made this color of. And I think that shows the solution set pretty well. So we know that it's going to be in there. And you might be able to see it a little bit better here. So I might come back to this when we answer problems. All right, so identify a point that represents a combination that meets the stylus requirements. Okay, so let's pick one inside of it that meets the requirements. That would be, I'm going to go with, I don't know, 12x. No, let's do 10 and 1. Right? 10 and 1 looks good. Over 10, up 1. So that would be 10 on the x-axis, which are haircuts, 10 haircuts, and 1 on the y-axis, with 1 coloring. So 10 and 1. So that would work. Let's go back and write that down. I like 10. Let me use the drawing tool here. I like the point 10 and 1. There are others. That's just the one that I'm going with. That would be 10 haircuts and 1 coloring. Identify a point that is a solution to the system, but is not possible or not likely in the situation. Okay, I'm going to go to this for this answer because a technical solution to this would be to do 12 haircuts, or no, 14 haircuts and -1. Negative right here at 14 and -1 would be a solution. Okay, so I'm going to pick that one. So 14 and -1. Okay, that is a solution. It actually would land like right down here. It would be in our solution set, but it's not possible because you can't do -1 hair colorings of your clients, right? You can't do -1 hair colorings for your clients. I guess maybe your clients could come in and give you a hair coloring and pay you, but I don't think that's going to happen. So that's that's impossible or unlikely, right? You might have picked something like, okay, do 1 haircut, or maybe, I don't know. That's the one that I think would probably be the best one to choose. You also could have chosen like an in between, I guess. I guess what they're looking for here is you could have chose something like 10 and a half of a hair color, right? Or 12 and half of a hair color. or 14 and a quarter of a hair color, or 8.5 haircuts and 1 hair coloring, right? You're not gonna do half haircut. Somebody's gonna be really mad about that. But yeah, I guess you could pick go along the lines of something like that. But that's what I'm going with. That's my answer for this. Sorry, this was a long video. It's a pretty long question. So I hope it was helpful. You guys have a good one. See ya.